Okay, it's 1 o'clock. Welcome to our next episode of an HDF clinic. There was a lot of activity on the forum, unlike last week, and so we'll get to that in a moment. I checked the spreadsheet before this meeting, but I didn't see any questions, and no, there aren't any questions, so it's good and bad. So before I sort of go through the usual motions, are there any questions at this point? No? Okay, good. Then I'll jump right in. Just a few announcements / reminders. On July 27th, we have that webinar hosted by Argonne, I believe. Introduction to HDF5 for HPC data models analysis and performance, presented by Scott Breitenfeld, and you can still register for it. Registration is free, obviously, and so yeah, still out there. Still, VFD Swimmer Beta 2 is out there for testers who want to give it a try. But then, yeah, we are getting really close to HDF5 113.2 release, which will also include Swimmer VFD. So if you don't want to jump on the beta, wait for 113.2. And then, yeah, we'll do that in our tips and tricks. Try a little demo for those of you who follow the forum. Yesterday, someone announced a VSCode extension for HDF5, and I actually had a chance to play with it, and it's looking good. But we'll see that in a moment. Okay, so those were the announcements I saw, and I'm going to pause here. Are there any questions so far? No. Okay, then I'll just press on.
Here.
Yes.
I did have one question. This was
sure.
On the soft data conversions that you went over last week.
Yeah.
I just wanted to, it was a two-parter. I just wanted to confirm there are no prepackaged soft conversions that are shipped with HDF5 or that get built with it. It's completely vacuous with regard to that.
Good question. Since we have Quincy here, Quincy, do we package any built-in soft conversions?
Well, there's the arbitrary float to arbitrary float and integer conversions. So I would definitely call those soft. I mean, they're strictly software related.
Mm-hmm, mm-hmm.
Is that what you're thinking of, Robert?
Are those discoverable through the typical soft conversion API?
It's been a long while since I've looked at that.
Yeah.
Not certain. I think if you said, plugged in a source and test, and they were interesting floating point, non-standard ones, and asked for the, called the is convertible, it should return true,
Mm-hmm. And
okay.
Then maybe with H5T find, it would be interesting, if you could do an H5T find on those, and then then you could get. It doesn't give you a name here, so probably they wouldn't show up under a name. But although the command T, does that have a name?
I believe that has a name.
No, it's just an enum. Yeah. Mm-hmm.
Okay. Okay, and the second follow-up to that
mm-hmm.
was, is there any way to publish a soft conversion? Would it entail, I'm assuming, some sort of a plugin API, but it looks like those might be completely local. If you write your own soft conversion routines, you can't publish them with the data.
Yeah, I mean, you could, in the sense that for archival purposes, of course, you could have, since if the source code, let's say, is C code, you could put that into a string and put that somewhere, or jam it into the user block, or so. Packaging wise, of course, it can be done somehow, but not in a standardized way. I guess that's what you are asking. Is there a standardized discoverable way of doing that? Yeah, and I'm afraid there isn't, because it's a transient thing. You load a library instance, and then you register your soft conversions with that library instance. But that the moment that library instance goes away, with that goes the soft conversion. Yeah.
It would rival something like a filter plugin.
Yeah.
Probably you're probably talking that degree of sophistication, probably that it would add.
Yeah. I mean, there might be a possibility though although again, it would be difficult to disentangle if you think about Lucas's HDF5 UDF, where you are basically doing the filter pipeline, you are massaging the filter pipeline, so to speak. Of course, you could a user-defined function, as he calls it, can depend on one or more other data sets, but in this case, one data set would be sufficient. And then for that user-defined function, you basically would apply your conversion. Although, no, it's a filter, it has the same data type. No, forget what I just said. No, I'm wrong.
Okay.
Yeah, no. Unfortunately, yeah. But then, of course, it begs the question, would that be a useful extension API? So making soft conversions sort of have a similar.
What's the use case here? What do you try
to it's just when we were going over it, it flagged my attention because of the possibility of I can write them locally to work with a data set, but just in the general sense of if that data set is published, making that same conversion for whether it's a UI purposes or whatever it might be, along with the data. I was wondering, how would I get that out along with the data? And it's not a showstopper, but it does sound like it's purely local at this point.
Mm-hmm. Well, I'd also say that I'm not certain it would be extremely beneficial. Some beneficial, yes, because you, as the publisher, you don't know what the subscriber, the client, eventually is going to have as their destination data type. So although you could provide some enablement with the soft conversion that you published, there's no guarantee that you would hit all the data types that a customer or client could come along with.
Okay. Mm-hmm. Okay. All right. So it might not be much of a solution in the end after all.
Mm-hmm. Although, yeah, Quincy, the use case that we had in mind last time that was actually triggered by some of the experimentalists we talked to, they were basically saying, well, yeah, in an experiment, when you typically acquire that data, it's bit fields typically. So just bit fields, and then you have to translate it both into physical quantities and engineering units and so forth, where you pick out certain bit patterns and so forth, and that represents quantities. And in that case, you are really looking at a data type conversion, and there are, you could argue that they are standardized in the sense that this gyroscope measures certain angles, and so just as a convenience to, sure, you could say, well, you could wrap that into an API, into a user API for that type of data, and that's maybe where it belongs. But it's basically it's sort of this old question of where does it live? Where does that code belong? Does it belong, like, let's pretend for a moment HDF5 were a database, then it's part of the business logic, so to speak. So then where does the business logic live? Does it live in the database, or does it live on some kind of client API?
Yeah. Well, in that case, you know both ends because you have the source and you're trying to put the destination in the file, and therefore you know what conversion you need to make. But after the data is in the file, the next client to come along to read it, I'm assuming, or even to write to it, unless it's a highly constrained scenario, wouldn't necessarily control what the other endpoint would be for their data types. So
yeah.
But like you say, it's a business logic problem. If you know that all the time it's going to be like this, then well, yeah, you could do some encodings.
Yeah. More like in a database, a view or a materialized view. And
in some sense, yeah, perhaps.
Yeah. Okay.
That's
thanks
good.
for the question.
That's good. Thank you.
Okay. Then last week we had that somewhat unexpected or rare situation that there wasn't really much traffic on the forum. Maybe everybody was on vacation or something like that. But that changed last week, where all of a sudden, there is a lot of activity. And again, what you see here is a biased selection. There's more on the forum, and I encourage you to go there. Someone was trying the read-only S3 driver and noticed that it would sort of break randomly, and the user was trying to use the read-only S3 VFD from Python, and it appears that sometimes there are, or in his or her particular case, there were connectivity issues maybe, but they traced it down. It was really AWS issues, but that unfortunately that S3 VFD that eventually is being called in this case does a poor job or no job at all trying to recover from those types of outages, or not getting a response back, and it doesn't make any kind of retries and so forth. On the other hand, off the top of my head, I mean, the read-only S3 implementation basically translates VFD calls into libcurl calls. So the S3 VFD, when you build it, depends on libcurl. And I don't know if libcurl has any kind of environment variables, for example, where you could set a timeout so that you could really push that down and say, let curl handle that, rather than us or the VFD writer for that read-only VFD having to implement that retry logic and so forth. There might be something built into curl, but I'm not a curl expert user. And then along the same lines, it appears that in Python there is this fsspec module which you can read in a way as the virtual file layer for Python, metaphorically speaking. So anything that looks and feels like a file, whether it is a real file or whether it sits in an object store or whether it's a fuse-mounted scenario, there is a Python module called fsspec, and that's it appears has some kind of retry logic and so forth built in those circumstances. And I think the consensus in that thread was that it's probably better to use and rely on something like fsspec, because it might take some time to, I think Dana replied, Alexander replied, and a few others replied. Dana said, well, we are revamping or revising that S3 VFD, but we can't give any specific dates or commit to a particular timeline on that at the moment. Then there was sort of, interesting enough, of course, a lot of good discussion happens at these HUG events. And I remember HUG 2021, there was, I think Werner Banger brought up the issue. He was basically asking, well, wouldn't it be nice if there was a H5 read or H5 write call that rather than asking the user to have allocated a buffer for to read into or write from, basically have a void star or something like that, where the HDF5 API would create some kind of a memory mapped buffer, memory mapped into the HDF5 file. And someone somehow picked up on that, so that came up again. And this user here commented, and he said, well, maybe it's not really, because especially in the write case, this would be quite a bit of work for the HDF5 library to detect, okay, what has changed in that buffer. And depending on the complex, I mean, for primitive types, not a big deal, but for more complex types, the logic that has to go into finding out what has changed in the buffer and where that needs to be written eventually, and because of the mapping, that could get pretty tricky. But I think most people perhaps would be interested in sort of the primitive types, the insta floats and whatnot. And then in that case, if you think about it, as this user suggested, what one might need really is, at the most basic level, a little more control over allocating space in the file without writing. And you could, on the one hand, you can argue, well, to a degree, you can do that already, although in a very blunt way, when you specify early allocation and fill time never, so that actually no writing of fill values or something occurs, but space is allocated, and then you can work with that space. But of course, in the case of a chunk data set, of a chunked data set, which in a real world scenario would be sparsely populated, maybe as far as the chunks are concerned. In that case, of course, that wouldn't be helpful. So a more differentiated approach that would let someone allocate certain chunks and say, okay, now I want to allocate this chunk or that chunk, or maybe even reallocate it in more complex scenarios where maybe compression is involved or filters. So I'd say interesting idea. But yeah, we will certainly think about it. But yeah,
I have some of the same hesitance you have, Gerd. Interesting, but I'd really like to understand the use case better. If the user think that they have exclusive access because they know that the space is allocated at this address, then they're going to get tangled up with caching and possibly type conversions. And like you say, it only works really reasonably for simple types, but things that are variable sized or something else, it's kind of on a very sharp edges.
Yeah. But nevertheless, I thought it was definitely an interesting idea in terms of frequently you then think about, well, forget for a moment about the high-level interface, think about in terms of primitive operations, which primitive operations would we need to support this? And I think this is definitely an interesting step in that direction. But then, I mean, even if we had this operation, because then the user would still have to do the whole memory mapping and whatnot themselves. But so it would be substantial work, but at least in terms of if for some reason that's what you want to do, then yeah, you can do it. And
yeah, well, like I say, possibly some region allocate would be the most compelling piece of it. Like, oh, I know I want this to be prepared. Just occurred to me, you were speaking that having the address of a chunk, again, besides the caching and type conversion and possibly filtering issues, there's also the notion that the library may decide that it wants to allocate some new space and release that space in the file, and your space is never going to get looked at again. It might get overridden by something else.
Yeah.
All kinds of, like you say, sharp edges.
Yeah. And then combine that with something like the onion VFD, for example, and then it can get really dangerous. Okay. Another comment, that I believe the same user, he was actually volunteering, which is admirable. He was interested in, and I think this was originally contributed by an external user, this H5D chunkito function, and it's there in 1.13, and he was asking, well, any chance or any idea whether this will get backported to 1.12. But then, of course, we have to keep in mind 1.12 is kind of nearing end of life. If you look at the published release schedule, there's going to be one more release, I believe 1.12.3, and that's going to be the end for 1.12 early next year. And but since we know that 1.10 is going to be around for the foreseeable future, then that might actually be a better target. So the main difference for some people that may not sort of be intimately familiar with this, the vol layer is in a way the big new thing in 1.12. However, we and others have learned a lot of lessons around that vol interface, and so 1.14 will really include the vol interface probably the way it should have been from the very beginning. And but otherwise there is no real reason to keep 1.12 around. That's why it's going away. But definitely, 1.10 will be maintained. It will see a few more maintenance releases. I mean, beyond the beginning of next year, probably throughout the year and beyond. But that might be a better target because you have this chunkito function, which basically says, okay, I get a chunked data set, and I would like to iterate over the chunks and invoke some kind of callback function as I do that. That is a good thing to have, and it's not really specific to any particular version. But the chances are, if that user is interested and eager to bring it to an earlier version, then 1.10 might be the better destination. Okay. Next one up, so this is an oddball. I'm somewhat surprised that this hasn't materialized or nobody has noticed that. Earlier, the user was reporting that, I believe it was an attribute, UTF-8 encoded, and it turns out that when that string data type is a variable length string, UTF-8 encoded, then the value of that attribute is displayed correctly in HDF view. However, if you choose a fixed size string with UTF-8 encoding, then somehow HDF view sprinkles in some fairy dust or it doesn't render the string correctly. And I don't know. It's probably a bug. I mean, presumably the content of that string in the file is correct. So if you use h5 dump, for example, or the h5 web plugin, the VSCode plugin, which we'll cover in a moment, it would appear correctly there. However, somehow HDF view seems to have an issue there. That's all I can say. I know Ellen is looking into it. Then there was an interesting question from someone, virtual datasets in HSDS. And John replied, and currently virtual datasets are not supported in HSDS. However, you can kind of wing it to a degree that in the most recent version, which I believe was 0.07 or 0.08 or something like that, the or no, it's actually 0.7, not 0.07, 0.7 or 0.8. John, over time, has continuously updated the representation of HDF5 objects in S3, and he introduced, for example, this concept of indirect references. So what you can do with that is, for example, you can construct a data set in a way a little bit like a virtual data set, where you describe in HSDS first and foremost, unless your HSDS domain, as he calls it, is backed by a physical HDF5 file, all data sets in HSDS are chunked by default. There is no such thing as contiguous layout. I mean, the chunk might be so large that it covers the whole thing, but in terms of as an S3 object and so forth, there is only chunked layout in HSDS. However, for each individual chunk, you can massage the metadata, so to speak, and you can either have the data stored in an S3 object, the same way chunks would be stored as a byte stream in an HDF5 file in a certain region of the file. However, with this indirect reference, what you can do is you can actually point at an HDF5 file that is stored as a blob, but you can refer to a data set and to an individual selection in that data set. So you can really, and that way you can cobble together very, very freely sort of bits and pieces from other data sets. And it's not the same as VDS. And the construction process, if you just look at the REST API call level, is I wouldn't call it tedious, but yeah, you have to go through quite a few motions to make that happen. But it is possible. But then, if you are interested in that thread, it's not over yet. So John is basically conversing with the user to try to understand, yeah, what is the use case, what is he or she trying to achieve, and but yeah, it's an interesting discussion. And then finally, it's just, yeah, it popped up today. Another good example, I think. It's certainly one of our main goals to make the access to HDF software as easy as possible in standard environments. And by standard environments, I mean VSCode, Visual Studio, Eclipse, and whatnot. But it seems to be that my understanding is CDT is like a project file in Visual Studio, for example, and someone is trying to just create a template or understand, well, how can I build, if I'm using MingW, let's say, as my compiler, how would I structure a project that has HDF5 as one of its library dependencies properly? And that seems to be more difficult than it should be. Now, I'm not saying it's all our fault or we are the only ones that can solve this problem or should solve this problem. There are probably more things going on here, how these Eclipse packages are distributed and how they are discovered and so forth, and what metadata is available to choose the right package and so forth. And then, of course, you could ask, what would that mean for us, what we would have to build in terms of binaries and whatnot. And yeah, of course, we are not raising our hand and sort of making all these commitments for all these things, but just from a developer perspective, I think it's definitely something that we should pay close attention to, because yeah, a lot of things start and end with developer convenience. And if a developer has the impression, what is this HDF5 thing? I can't make it work in 5 minutes or something like that, and then they lose interest. We don't want that to happen either. But yeah, this just cropped up, and anybody who has any hints or suggestions should definitely chime in. Which brings us to our last topic. We are almost out of time. So is that VSCode extension for HDF5. And when I saw this, I'm not running VSCode as a desktop client here on my machine. However, I'm familiar with GitHub Codespaces, so that's one of the ways how you can spin up a container from GitHub, and then you get a VSCode interface. And then this is a VSCode interface, which means you can, there's the marketplace, the VSCode marketplace, and you can install all these add-ins, and the H5 Web add-in is one of them. You can also, if you don't want to use GitHub Codespaces, you can set up your own code server. I just added the link here, and then still run the browser plugin. And just to be safe, I took a screenshot here, but I'm going to switch over here. So keep working. Yeah, it was about to shut down my code space here. So this is just my, I should probably, let's see, Control plus, yeah, make this a little bigger. So this is sort of the typical VS Code. I don't have to explain that, what that looks like. Here you see the extensions. And so of the extensions that I have installed at the moment, there is the H5 Web extension. I also have GitLens and C++, C++. Here is the, I actually checked out the HDF source tree. So, and here I have a netcdf file. That's interesting. Someone in that thread already commented that for some reason, and I'll be interested in seeing where this goes in the thread. Somebody said, well, aren't netcdf4 files HDF5 files? And yes, yes, they are, of course. But someone said, well, I just took that netcdf4 file and changed the extension to .h5. And if I try to open that in VS Code, it actually comes back and says, expected a valid HDF5 file. So for some reason, something in the plugin prevents it from recognizing this as an HDF5 file. And it's strange because it is an HDF5 file, but it must be something special. But then here I took an HDF EOS file, and I can load that, and it's a 50 megabyte file if I remember correctly. So it will take a moment to load. But then once it's loaded, I'm a little confused sometimes by how many times I have to click. If I have to click just once, and then it takes a moment to load. Here we go. Yes, so for all of you who have seen the H5 Web plugin, here it is. And this is, if you're familiar with HDF EOS, that's sort of the typical HDF EOS structure. And so you can see top-level information about attributes and so forth. But I'm just going to jump straight to data. So in this case, it's gridded data. And I'm going to jump to 1 here. And so this shows me attributes and whatnot. But the beauty of it is I can actually see this rendered. I'm not an expert on how you can change color maps and so forth in this environment, but you can certainly go ahead and do that. And then, yeah, you can also switch to line plots by selecting a certain row or column and so forth, or you can also see it as bare bones numbers and so on. And it works, and it's in the Visual Studio Code environment in the browser in my case. And then, yeah, it's actually pretty responsive. So as I make these changes here, it reacts pretty much instantly because, yeah, it's all, in this case, running in the browser. There's no going back to some kind of server, or it's all running in the browser in this case. Anyway, I just thought I'd show that, and yeah, it's definitely an interesting development. And let's see, I want to go back here. An interesting development, and yeah, stay tuned or tune into that thread. I'm sure there are many more interesting things to come. And it's definitely, it's a nice tool. It's something we talked about just before the last hug event at EDA, and then at the hug event itself. And so, but it looks like, yeah, hey, the community is really stepping up here and doing some great work. And yeah, so that's where we are. Thanks for coming today. We are out of time, unfortunately. Come back next time, and we'll talk more HDF5.